We have already seen the calculation of loads in different parts of the beam, or otherwise it is called as analysis, from video number 1 to 7. And then we have already seen the method of designing of slab, method of designing of a beam for its bending or the tension rods or compression rods. Then we have already also we have seen this the finding the depth of the beam also we have seen up to the previous videos. Now we are going to see the design for shear in a beam, or the in other words it can be said as the calculation of number of stirrups or vertical rods or rings, etc. in a beam. Continue the video. I have given the video in the method required to be designed as per IS 456. Design of a beam for its shear strength. This calculation of vertical rods, calculation of rings, all the same thing. First we are going to take the group number 1, for which the working shear force, which we are giving the name as P. Its shear force is 138.58 kilonewton. So factored load means including factor of safety 138.59 into 1.5. The total, this is factored load or design load. Design shear stress, shear force. Then these are the section parameters, which means the concrete is M20 concrete, Fe 500 steel, width of the beam is 230, depth of the beam is 450, the total width. The cover to reinforcement is 30 mm. So therefore, what is the effective depth? Total B minus cover is called the effective depth. Area of cross section of the beam is this much. How this much is? This is nothing but breadth 230 into 420. Effective depth is equal to this much. Working shear stress means the working factored shear divided by area of cross section. Area of cross section, this one is the area of cross section, this is the factored load, into 1000 is for converting this kilonewton into newton. The on calculation it comes as this ones. Then you before starting the design, we must find the what is the percentage of tensile reinforcement we have already provided in the beam. That is, in the previous video we have already designed the tensile reinforcement is 3 number of 25 mm rods. This rod comes in the top side at the support point. If we convert this into percentage, that percentage means area of cross section of the concrete divided by area of cross section of the steel is 1.524 percent. You make it very clear, allowable shear stress with the available tensile reinforcement is this much. How to find this? IS code books. IS 456-2000. Table number 19 we need. Yes, this is table number 19. This gives the allowable shear stress, that is, it is called tau C. Tau C. This is the notation by IS. Left side, the column, the percentage of reinforcement are given. In the right side, the allowable permissible shear stress for various concretes have been given. Using M20 concrete, and the reinforcement is 0.72. Yes, sorry, 1.54. The reinforcement percentage is 1.54. This is 1.5. This is M20 concrete. For this, the allowable permissible shear stress is 0.72. Newton per mm square, this has been given here. Okay, that we have taken here. Now on seeing this, design shear stress, which is design shear, the S1 is the design shear. Design shear stress means available that the existing shear stress available in the beam is 2.15 Newton per mm square. This is more than the permissible shear stress. Yeah, additional reinforcement has to be provided for resisting the excess shear force. Design for additional shear stress. Shear force taken by tension reinforcement only. Cross section of the beam into that S2 we have already defined this as S2, which is the allowable shear stress, while the tension rod only, which we have already taken as 0.72 from the table of 19. So put this here, this cross section 230 by 420 is cross section into 0.72 is the Newton per mm square shear stress, allowable shear stress. The total comes as this much, and the total kilonewton we have converted it into kilonewton. The balance shear stress, this is the shear force which can be taken by the reinforcement of tension rods only. So the balance shear stress, available shear is 207.88 kilonewton. The shear taken by the tension rod is 69.552. The total is 138. Balance is 138.33 kilonewton is the balance shear stress, for which we have to provide additional reinforcement. Okay. Formula for the shear stress is this one. This is given in class 40.4 of IS 456. This is the formula for vertical stirrups. Vs is the same formula I have given here. Ps equal to 0.87 Fy into ASV into D by SV. What are the meanings? BUS means the balance shear stress, which we have arrived as 138.33 kilonewton, and AS means area of steel for vertical shear. Then D is effective depth of the beam. SV is spacing of vertical stirrups. Spacing of vertical stirrups. So this formula can be algebraically, we can write this way. SV equal to 0.81. This denominator comes to numerator, the numerator goes to denominator. The same formula comes like this. Presently we are going to try the same formula with the use of atom rod. Atom rod diameter is the cross section of atom diameter is 50.24 mm square. As we are going to provide this as a ring, so there will be two rods in the vertical direction. So this vertical direction means this is also called as two-legged, or two vertical rods is called as two-legged rods. Two-legged 8 mm rods. So one rod diameter is 50.24. So total area is 100.48 mm square. This here is here. So using the same formula, we are going to put all the values. 0.87 into Fy 500 ASV. We have this ASV is area of vertical stirrups. 100 point. This is not tension rod. This is only for vertical rod. 100.48 into 420. This is effective depth of beam divided by this 138 is 138.33, the balance shear, into 1000 means it is converted into Newton. This is available is kilonewton. We are converting into Newton. So this is the formula. On simplifying these things, the value obtained is 132.71 mm. It means a ring in atom rod should be provided at a spacing of 132.71 mm as per the design. So, but we need to check these things for another two numbers. This A, we have designed it as per the formula. Then B, spacing between two rods can be a maximum of 0.75 into D. That is 0.5 of into D, depth, the effective depth. It comes as 313 mm. This is more than that design. So this we need not worry. Next is C. There we should provide certain, the IS code says in 26.5.1.6 it says that there should be a minimum shear reinforcement. That minimum shear reinforcement is given in this formula. 26.5.16 class 26.5.16. This is a minimum shear reinforcement. It has been given in 26.5.1.6 that minimum shear point. The minimum shear reinforcement in the form of stirrups should be provided such that ASV by B into SV should be equal or must be more than 0.4 by 0.4 by 0.87 Fy. Whereas ASV, we have already seen that this is area of steel for vertical rods. SV, spacing of steel stirrups, breadth of beam. Fy is characteristic strength of steel, which is in our case it is F500. So we are going to take it as 500. On see, with this formula we are going to find the minimum shear minimum which has to be provided in the beam. So this is the formula on substituting these things. The star means this is auto vertical. The multiplication is termed is printed as a star. On simplifying these things, the spacing comes as 475.09 mm. So the spacing should be either this one or this one or this one. Among these, the minimum spacing should be provided. So 132.71 is the minimum spacing required to be provided if we provide 8 mm rods. Okay, we shall try the same thing with the use of 10 mm rods. If we try with the 10 mm rods, the area of one rod of 10 mm diameter is 78.5. For two leg, the total comes as the two rods 157 mm square. On using this, we are finding we are arriving that the spacing is 207.33 mm, and the minimum is as derived previously. This is 315 mm. In the C category minimum reinforcement, this is 742 mm. So in this, the minimum should be arrived. Whichever is smaller should be arrived. This is 207. So on combining these two, we are arriving that we can use 8 mm rod at a spacing of 132.71 mm. So this is the method how to arrive the shear reinforcement in a beam. Okay, in this I like to do these calculations at the simplest form using the Excel sheet. Please continue for another 2 or 3 minutes, please. This is the same Excel sheet I am giving you in a little wider in the top. So this is Fx means whatever we click here, whatever we click here, that number is shown here. 230 I have clicked here. Fx box in the formula bar, this shows as 230. But I have entered the certain calculation. These are coming under some calculations. Above value into 1.5 is the factored value. This we need not have to calculate this using calculator. This we can do this in the formula bar itself. That is, it means this one you print it as equal. Equal means the it goes to calculation purpose. This is the shear available as per working level. This one into star is the into 1.5. You enter. This calculation automatically comes. The computer automatically calculates it and gives that print. In this way, these are the boxes which are shaded in green color are the calculation results given by the computer itself. If we provide everything by computer formula, if we do these things once, then the same thing can be produced for any longer time. For example, by changing this shear force into 90, suppose the next beam kilonewton is taken as 90 and printed as 90. Given enter, all the calculations have all changed and the total value comes separately. But however, the boxes shown in oranges should be checked. The beam size, some of the beam's size could have been changed. We ourselves could have assumed in a different size. There we should change. This in that beam, then number of rods, 25 number of three rods we might not have used in that beam. So that we should check it and we should give this calculation by manual method. The orange lines. This one by seeing the tabulation, this has to be taken from the table based on the percentage of reinforcement. The permissible shear stress in the beam should be seen in the tabulation and should be printed here. Likewise, this also maximum permission stress. So by following these methods, we can do any number of beams at a simplest way by just checking the values given in these orange cells. Okay. So you might have understood a little better about this design of vertical stirrups for the shears. Please like it and share it to your engineer friends or architect friends. Thank you.